All right, welcome everybody. It's 10:05 on September 17th, getting ready for our lab meeting. We've got a pretty full house today. I guess Barrett is on his way in, so we'll probably see him as well. And Taryn is joining us. So Taryn was a graduate of the department a couple of years ago, just last year?
Yep, 2020.
2020. And she's working for Esri, and she does work with drones and photogrammetry, like for Esri. So you just got a new drone?
Yeah, I took it on its Virgin flight yesterday and didn't crash it, so I'm really proud of myself.
So we'll do a couple of introductions for your sake, Taryn. You know me, but we'll just kind of go around the...
Hi, I'm Andrea. I'm undergrad right now, I'm a senior.
And what are you working on?
I'm working on PPK, processing sensors, RTK, GPS. I just started, so.
Cool.
Hi, I'm Addison. I don't know if you can even see back there. I'm the person but I'm also an undergrad. I'm a senior. And I'm studying meteorology and geography, and I'm kind of doing photogrammetry, indoor mapping, that sort of stuff.
Cool.
And here's Barrett. Made it.
We're doing introductions with Taryn. And joining us, she's a recent graduate of the department. It works for Esri doing drone and photogrammetry stuff.
I'm Barrett. I'm a senior undergrad. Just started here, working with the other undergrads on stuff. Glad I can make it this morning.
Yeah, thanks for doing it.
Hey, Taryn, it's Johanna. We
Oh, hi, Joanna. How's it going?
together, and I'm still here, so.
Hey Darren, this is Gunjan. I'm a grad student here. It's my second semester, so I'm also working with drones and doing urban thermal modeling and planning to do some perception study on the visualization. So yeah.
Well, cool. Well, thanks for introducing yourselves. Sounds like I probably should have gotten more involved with Tom when I was an undergrad, being a different spot right now. But sweet, yeah, I'm gonna go back to turning my video and mic off just because I'm working right now and I don't want y'all to have to listen to my mechanical keyboard.
Sure. Yeah, no problem. We'll finish the introductions with a couple of people that are joining us remotely. So Colleen, you want to do a quick introduction?
Hey Taryn, I'm pretty sure we were in the same programming class together.
We were indeed.
Yeah. So you know me, it's my 5th semester and I'm hoping to graduate this semester. I'm doing research on least cost path analysis and how it can be used to potentially predict archaeological sites in the Antisuyu, which is the part of the Inca Empire that borders the Amazon basin or goes into the Amazon basin.
Awesome.
Chandler, you still with us? There we are.
Yeah, I'm here. Hi, I'm Chandler. I'm a 4th-year landscape architecture student, and I'm working with Dr. Pengel to try and combine landscape architecture with geovisualization and remote sensing.
Awesome.
Chandler, do you know Jack Rosenberger?
Jeff Rosenberger?
Jack Rosenberger?
Wait, what's his first name?
Jack.
Doc Rosenberger.
Jack. J-A-C-K.
Jack Rosenberger.
Yeah.
I do not. Is he one of the LAR professors?
No, he's a landscape architecture working for the university, but he's not faculty. He's like a landscape architect.
Wait, did he do that? Did he do the plaza right outside Kogel, the one with the descending staircase?
I'm not sure, but perhaps, yeah.
I think there's a local landscape architect that does commission work for the school, and he's built some parts of campus, and he gave us a talk, and that might be him.
Okay. Barry, if you're pouring, my coffee cup is right by that. All right, I'm gonna get the screen share going here. Nice big crowd today. All right. So a couple of quick announcements. There is an OpenCV talk. So OpenCV, that's Open Computer Vision. they've got a lot of great stuff kind of going on. So you can download OpenCV. It's part of kind of the lab Python environment that I have you guys install, but we don't use it a lot. But it comes in handy for a couple of different projects. It's got a whole photogrammetry package inside of it that we haven't really done much with yet, but could potentially be useful. And they give these weekly webinars. This one actually got canceled, but I think it's if it gets rescheduled, this is somebody kind of working on OpenCV and robotics. So I think there could be some good stuff there. OpenCV also just launched their Oak Lite. So the Oak D toolkit is kind of this like depth sensor, like a Microsoft Connect or like some other technology like that. But it's got a lot of deep learning support built into the hardware. So it can do a lot of like image segmentation and stuff like straight out of the gate, which is really great for certain robotics applications. So we have an Oak D kit, actually, it's right there. It's that AI kit in the corner. But this Oak Lite is like $90 versus $200, and it's supposed to be smaller form factor. And so I just ordered one. There's that Kickstarter if anyone else is interested in getting one. I'll probably get one for the lab at some point, but getting the university to fund Kickstarters is not necessarily easy. So I just paid for it out of pocket, and we'll see how it goes. A lot of people are working on getting the LiDAR scanner, the Regal, up and running. And we needed a couple of connectors. Did you guys bring the battery in for that?
Yeah, I'll have an update about that on my report.
Cool. So a lot of kind of bits and bobs to try to kind of get that going. We also got some new GCP targets, which Gunjan is very nicely demonstrating here. They have these new, they have this like flap in the center right here that kind of lifts up. So that's why I wanted these particular ones, because if Gunjan is doing these thermal ground control points, then he can take a temperature reading just by kind of lifting them up and see how it goes. I don't know whether it's worth it or not, we'll try them out. I'm also kind of interested in getting another way that people do these is with like bucket lids. And maybe if undergrads are interested in just manufacturing a couple, if I bring in some paint and some bucket lids. I like those a lot because they're really light and durable, and you just, toss them on the ground, and they, if it's not windy, they mostly stay there. So a little easier setup sometimes for those. I have been trying to get the RTK GPS N-Trip unit up and running again. It was in my attic, so that's what I presented last week. This time I crawled up on my roof and I had a hard time finding a good spot for it, but I ended up kind of wedging it in here on the siding, which I knew wasn't a great placement, but at that point, my feet were getting all burned up because it was a really hot day on that roof, and so I was about done. And I put the rover outside. This isn't a great photo of the rover, I should have gotten closer, but just to see what the corrections would look like and see, like, not just how this was doing, but how the actual corrections would turn out. The answer is not well. So even though the base was getting 24 satellites, which isn't really enough, right? That number should be about like 31 would be better. So you can tell already that like the placement on the house is like preventing it from getting a good signal. And then a lot of the signals are not necessarily good. So in this particular screenshot, all of the bars are red. They're green if it's above like 40. So that's bad. And then the rover is getting 19 satellites, which is not so unusual because those are going to be, you're going to be on the ground, you're going to be doing stuff. So that number is almost always going to be lower, but this number should have been higher. You can see it says it's getting a float status, right? So there's these 3 different kinds of grades of correction. There's single, which is no correction. Float means you're getting some correction, and then fix means you've got a very tight lock and getting good corrections. So this is kind of that middle ground, which ordinarily should be sort of like maybe sub-meter accuracy. But if you leave it there, you find that it's reporting standard deviations, which fluctuate a lot, but in this particular screenshot on the order of 3 meters, which is terrible. I took the points for a while and it put me here. I did it again and it put me there. The actual location of the rover was about there. So we're off by tens, dozens of meters. It's pretty bad. So functionally unusable, so I turned it off. My new plan is I already bought this weather vane rack mount thing, and it's going to go on my roof, and I'm going to put it on that. And I've got actually got a slide for this. It's going to go right there.
My stepdad is also a professor, and he was randomly really into weather and was trying to establish like a big weather system on our house, and it wouldn't work in the attic. And so I don't know if it's something he bought, but essentially he had a big pole that like comes out of those little slots and sticks just above the house, so there was no like house interference.
Comes out of these slots.
Yeah, like
then
it's
goes
coming out
up.
of our
Yeah, that-
attic ventilation somehow,
It's like
and it
a
just
hill.
sticks right above the house, so it was not getting
Yeah.
interference.
Ask him about it. And
Yeah.
send me a link. That was my idea, and I was like, by the time I like build that, it's
Right.
going to be.
Well, hopefully
So-
it's like $15 on Amazon or something.
Yeah, send it to me. That'd be great. Yeah, that could be a good thing. Hopefully, what I don't really want to do is drill into my roof.
Right.
I don't want to poke holes in my roof for this, but I bought some like pieces of aluminum to kind of make wider feet, and so my hope is I can just kind of set it on the top. It's not going to be bearing any weight. That it kind of weighs like a feather, so it should be fine. And then the substantive stuff that I was working on this week was trying to get Jack's whole photogrammetry beach stuff. Making another run at that. This data set is super problematic. It's like 6,000 images of 22 transects or something like that going across the beach, and just has been a real bear trying to get it to come together. So for his thesis work, he essentially had this method where he used the gun control points along 3 transects of the beach going like transverse to these. So he's got these 3 transects here, and then he used those to kind of manually say where each transect was, and then used a bunch of manual tie points, and it still didn't come out great. We are essentially hoping to publish some of that research, but I want to give one last try to sort of seeing if we can resolve some of these issues. So one nice thing here is this is a much simpler method. So here you just set all of the heights to a fixed height. So in this case, I think I just set it to 0, but you could just set it to the median altitude of the run. The problem is the beach is sloped, right? So you're going to be getting this parallel thing that's parallel to the beach. So it's going to be sort of falsely thinking it's this way when it's really that way. But I can fix that in post, I think, is my hope, is like make an adjustment there. And with the right combination of settings, you actually do get it to come together. So all of the cameras calibrate with this setting set. This linear shutter turns out to be super important. The difference between using the global shutter, so Johanna and Jack and I had a meeting on Wednesday where we were sort of talking about like how all these different things impact the reconstructions. And who was I talking to? I don't know. But these settings matter a lot. Like if you've got a good data set and it's and you just plug it in and you hit go, sometimes it spits out a perfectly good model. But when it doesn't, then you've got to sort of figure out why not. And these like pole photogrammetry things tend to be a lot more sensitive to these settings. So the just one little switch changes it from a total garbage reconstruction to a good reconstruction. But notice that the reconstruction time is quite a bit different. So 7 hours versus 16 hours. So this is a huge data set. We don't often use the 6,000 image set, but this is kind of what the orthophoto sample looks like. So this isn't actually the finished orthophoto. This is the orthophoto that you get after step 1 in Pix4D, which is really not too bad. There's a couple of, you'll notice that there's still some artifacting in here, right? Like, so he walked out to here. So all of this stuff that you're seeing here is sort of artifacts of the image, not sort of the beach color. And then I don't know why, but his bottom transects went out a little bit further, and you can totally see that. So like, what you see is a combination of processing plus what was actually there. But it's not so bad. I think this image looks okay. The DSM, so So that's the digital surface model. This is the reconstruction of the land surface. Don't worry so much about these. The edge stuff is all just caused by, it was outside the bounds of the data collection. So the edge reconstructions of a photogrammetric model always are terrible. And it's nothing to worry about. But on the inside, it's really rough. It's rougher. You know, you can just tell visually that this is rougher than the beach actually is. You've got this big kind of lump in the middle, which is a bigger, what we're calling a ghosted surface, where the reconstructions happen in sort of multiple planes and it doesn't quite know how to get them to stitch together. And that ghosting is essentially what's happening in miniature all the way through this. And that's why there's all this like texture that isn't on there. So I'm probably going to try adding some manual tie points. Jack has a bunch that he's already made, so I don't have to go back and redo all of those. So I'm going to try sticking those in there and just sort of see if that helps it like finish snapping together. A couple more ideas, but the goal here is to be able to take one of these full photogrammetries and compare them at least to another full photogrammetry, if not to the drone imagery also that we collected. Ideally, they would all go together and you could compare anything.
Did you happen to look at the report that it spits out after the first step? Does because I'm curious if, like, remember that image I showed you where like there wasn't a lot of
I did look for that. Yeah. It was weird because of the density of the photos. It was actually hard to get a sense of where those were.
Yeah.
But it looked to me like it was exactly as you pointed out, as there weren't a lot of common tie points between images. So
Between like one direction.
exactly. Yeah. So I actually do have some. I mean, I'm getting pretty interested in whether like a different pattern of data collection would have really helped this a lot.
Mhm. Me too.
So.
Yeah.
And maybe that's true. I was thinking the other day that might be true for drones. So when drones fly these missions, it's all transect, right? It's down and back and down and back and down and back. And that's what we replicated here. Is that even the right way to like gather data when you're flying a drone? Like you could do it in a whole other like spiral pattern, kind of moving inward. And there's no reason why you couldn't do that. It's just like nobody does it that way. So
you're curious if he had walked in a different way with the stick, maybe it would have turned out differently.
right. Yeah.
Yeah, in one of the error reports, basically it has all of the cameras and then it like visualizes how many 2D tie points are between each image.
Mm.
And there's a ton of 2D tie points going in the same direction, but the photos coming back in the other direction have almost no 2D or like no 2D tie points that that are common with the parallel line. And so like connecting those two, I think maybe it's having problems with that.
Yeah. I think, it might, I think that might help with this is splitting this into separate projects and then trying to tackle half of this at once so that, one of the things that you'll learn as you kind of work on this stuff is that the smaller you can usefully break the problem down, the faster things go. And there's probably no reason to process all 6,000 images here. I could probably do a third of this or half of this and then run it in, probably less than half the time because the processing time kind of increases a little bit exponentially. So anyway, some things for the future. I was glad that this finished. I tried adding, there's another couple of settings where you can add geometrically verified matching and rematching. I thought those would help and they made things worse. So that's a bit of a mystery to me why that would make things worse unless they start sort of off, as it's rematching, the fragmentary nature of the whole thing just starts to get worse. I don't know. It's a working theory. I don't really have a very good explanation. Last week's goals were to meet with Jack and Johanna, which we did on Wednesday. So our goal is to write a paper on what we collectively know about full photogrammetry, which is kind of a lot at this point, and to try to get that into a paper of some kind. So we're going to assemble our sources. We set up a weekly meeting. We got a little Slack channel going and come up with a list of best practices. I'm still working on this idea for testing the ideas for doming and the reconstruction problems with Jack's data set. Super slow going. One of the things that drives me nuts is that manual tie point placement does help a little bit as you do this stuff. But Pix4D it gets really slow, unusually slow when you got 6,000 images. I don't know why it's so laggy, but it is. And so integrating MTPs is a problem. And I'm kind of wrestling with how much time to put into this anyway. We've already put hundreds of hours into trying to figure this out, and I don't know whether the dozens of hours that I have left are going to really make a big difference, but I think it would make the paper a lot stronger. So it's tough. But on the other hand, maybe it's better just to send back the feedback and then deal with it then.
Just curious, how long would it roughly take to like assemble, send the paper out, stuff like that? Like how long does it take to get the paper?
Well, it depends on the state. So Jack's thesis was essentially written as a paper. So a lot of that work is mostly done. But this piece where the pole photogrammetry stuff didn't come together, he was just basically like, we're trying a bunch of stuff and it didn't work. So like, none of those comparisons are in there. And journal reviewers and editors aren't going to love that. They're gonna be like, okay, well, that's not publishable then. It's not even necessarily like a negative result, which is sometimes publishable, but this is kind of probably like, all right. So yeah, how long does it take? I tell people that it like a journal article or a master's thesis, which is kind of related to that, is maybe about 1,000 hours of work in total. Project start to project finish, not just writing a paper. That part's not as long, you know, but it's still, I don't know, if you had an open runway and you could really just kind of sit there and write, how long would it take? 2 weeks? I don't know. It really depends on the paper. What do you think, Joanne?
Yeah,
But if the work and the analysis was done. See, I was doing both at the same time, so.
Yeah, so if everything was done. It depends how fast you're writing. For me, it would take probably longer than 2 weeks. I'm a slow writer. But yeah, it depends how long people have to devote to that one particular project, right?
Gotcha.
Yeah.
A million other things going on.
And this paper is on more than just the photogrammetry, it's all terrestrial SFM stuff that you guys have done, or?
So Jack did 3 drone flights as well.
Okay.
So for 3 months he did, and each month he did a drone flight and this pole photogrammetry on a beach. And so the idea is you could compare kind of the thing over time, sort of see what happens, and you could compare how well the pole photogrammetry does at capturing important dynamics versus the drone. Yeah, lots of angles. And so the idea was, you know, another paper to sort of say, is pole photogrammetry sort of appropriate for this application? Is it better? Is it worse? And right now the conclusion is it's worse. But flying beaches is not always really easy because there's a lot of people around a lot of times on beaches that people care about. And so you can't fly drones over people that are not part of your collection.
Did he have to like reserve an area?
He did his kind of in a
Just went up to this beach that no one goes to.
yeah, it was like in an island and he had to take a boat there. So he was the only one there.
Oh,
That's
wait,
all.
where was it?
This was in South Carolina. Yeah, a little bit north of Charleston. Yeah. So that's a big limiting factor. And the rules are kind of constantly evolving. So now they've got 3 different classes of drones that some of them can kind of fly over people depending on the rules. If it's super light, then you can kind of just do it, but it's like really light. You remember what the limit is on that? Like 250 grams or something, right?
It's about how light the thing is. It's like a safety.
Yeah, it's like risk to injury. And then to fly over people at all, you're going to need like propeller guards, right? So that they don't cut people as they come down. So it's a combination of like that and the weight and some other stuff. But that's why I'm really interested in tiny drones, like little micro drones. Like, you know, DJI has a new drone that's really, really tiny. And the cameras don't necessarily have to be that great. Like you can be like, I would trade a worse camera for being able to fly over people without restrictions if that were a thing. So like flying on campus is really hard. Like I've just kind of stopped trying because you've got to have visual observers and you got to mark up the thing, and it's just like way too much work to make it useful. All right, and that's it for me. I guess I didn't put my goals for next week down, but essentially it's to keep on working on the this stuff. right, that's it for me. Kendra, you want to go next? Oh yeah, you're off this week. Johanna, you got stuff this week?
Yeah, put it in the,
You guys
I think we'll need to turn the screen share back on. So everything's turned off.
That's right. It's like the apple, you know, like black turtleneck with jeans. Yeah.
in the left. All right, so. Okay, I'm really bad at doing the goal thing, so I'm sorry. First thing, this Brush Mountain project that I think I mentioned a year and a half ago in this lab has been resurrected. But basically, there's this new trail system near the Gateway Trail. This is terrible map that they made because there's like way too many topo lines. But basically, Heritage Park is like right here. And there's some mountain biking trails that sort of go off this main gravel road that goes up. And Dr. Mike Cerise and JP Gannon over in the forestry department are interested in setting up some permanent trail transects, as well as using an infrared use counter at the start of the trail system and incorporating trail surveys over the next couple of years. So Cerise has a master's in forestry student that he's bringing in to head this project basically, and we're out there helping as well. So this is kind of what we've come up with for establishing these permanent trail transects, but basically we're going to put like a rebar on one side of the trail, find a large tree on another side of the trail, use a self-leveling laser to then put in a nail on the other end, and then that will serve as basically every time someone goes out there, they're going to set up a line, like a tape measure line that goes all the way across, and they're going to take measurements down to the trail tread at the same interval every single time. And I was thinking maybe this would be a great place to use as a methods testing ground for some structured for motion protocols for some validation data that I'm trying to take out in Joshua Tree, California. And so, yeah, I just kind of wanted to put that on the radar, and that also might be good just in general for other kinds of tests we want to do, because we're going to have basically, eventually we'll have data for maybe it go out after rainstorms and measure it, or after high use weekends and stuff like that. So we have the tread changes over time. So another thing, I was looking at some papers about maybe camera calibration and structure promotion. I found this paper from Baptiste Marteau, application of structure promotion photogrammetry to river restoration. They are using drones, but they did some kind of involved stuff to calibrate their camera. So first, well, first of all, they were using GoPro Hero 3. That's a pretty old GoPro camera. And then they tested several parameters before data collection. So they wanted to evaluate the different shapes, sizes, and colors of their GCP markers to figure out which would be best. And they also used certain calibration distortion coefficients, which I guess are advised using fisheye lenses. I haven't really looked into what this means, and it sort of seems that Pix4D probably automatically does that with their stuff. So then after that, they designed an experiment to test for the ability of the camera to capture details at different distances and evaluate the errors associated with different flight altitudes. So basically what they did is they grabbed two posters with this checkerboard figure and put two semi-spheres, glued two semi-spheres to it from diameters from 1 centimeter to 10 centimeters. And then they took pictures from distances of 5, 10, 30, 40, and 50 meters to simulate flight height. They surveyed those positions and shapes using a total station, as well as like 100 other random points on this checkerboard. And from that, they could compare the point cloud from the GoPro to the total station points and figure out what kind of error they had from either. So basically their RMSE ranged from 0.015 to 0.192. And the residuals were lowest at 5 meters from the board, which is, I guess, expected, but consistent 10 to 20. And at distances greater than 30 meters, residuals were the same magnitude as the size of the hemisphere. So they concluded that their optimal flight altitude is 20 meters. And I think for them, especially having like the wide angle lens of the GoPro, but they were specifically interested in microphotography. So for them, it was really important to have that low, that balance between the two. So I thought that was interesting, somewhat useful information. I've never seen other papers go to such lengths to sort of measure some of this stuff. A lot of papers that I read on structure for motion terrestrial data, at least, sort of go with settings that are already available, or just go best practices. So another thing I did in the last few weeks is I found this researcher, Piotr Tomczak-Kopczyk from Poland, and he's doing similar trail stuff as I am. He's using like terrestrial structure for motion and LiDAR data. And he paired LiDAR data with structure for motion data. And I was curious, how did he pair the two without actually having a high quality GPS? And he did something pretty involved, which I thought was kind of funny. And I don't know if this is at all useful or not, but I decided just to report on it because it was a conversation that I had in the last few weeks. So he found major trees or landforms nearby. He triangulated positions of his GCP markers to a clear point on those 3 different landforms. And then he took distance and azimuth measurements, the distance and compass measurements from those. He then found those landforms in the LiDAR data by literally going into the point cloud and finding that tree.
Okay.
And then he reverse found the GCP positions using these. And we use those for the GCP positions for the structure for motion data, and he paired with the LiDAR. So this is kind of what it looked like. For he found these in the field, took distance and azimuth measurements, and he also used, I was curious what pattern he used to collect the terrestrial structure for motion data, and it was like this circular pattern, and he actually has a better diagram in the paper. Here it is. He took pictures going inwards at a oblique angle in a circular pattern, sort of keeping two common GCP points in between the two, like that.
Okay.
And from what he says, it seems like he got pretty good reconstruction of the two. He compared transects from the LiDAR and the structural for motion data. And, so
Nice picture.
yeah. So that's that. And so finally, something I want to put on people's radar. I'm totally unaware of this, but the geography program has a GIT certificate, which is very easy to apply for and get. You just, as long as you've taken a certain, like 12 hours of geospatial coursework in certain categories, which I feel like a lot of us have, you can get a GIT certificate.
Okay.
And anyways, you just need a signature once you've taken those classes and you have this certificate. So
Oh, yeah, that's great.
anyways, that's all I have for today. The goals for next week is to continue working on the structure for motion paper collection and reading those kinds of papers, and I think next week we're gonna go out and maybe start setting up permanent transects for the Brush Mountain Trail project.
Sounds great.
Yep.
Cool, thanks. I'm just gonna go around the table, I think.
Well, I kind of struggle accessing my slides sometimes. Got to get to the drive. Is there Wilson 2021 right here?
Yep.
Yeah. 17. Cool. Zoom.
You just do the whole screen, that works fine.
Is that what it? Is that what I did?
Yep.
All right. Cool. How do I pull up? I guess it doesn't matter. All right. So lab report. I think last week I had like some rough notes on the photogrammetry notebook that I was working on because I felt like a lot of my classes I've learned about LiDAR, but I didn't really understand how much photogrammetry y'all do here and how useful it is. So my notebook's coming along, it's a lot better. At least I know a lot more. As far as when I try and make these, I try and pretend that I'm like teaching it to someone else, and it kind of is just like a wall of text. And I feel like if I wanted to, I could go and kind of organize it better, make better pictures, and make it more informative. But this was just a minor thing. So Wednesday we had the undergrad meeting, which was really great. First time I think we had everyone, all the undergrads. First, well, I guess you weren't. Here.
Yeah, I can't.
Yeah. Well, 3 out of 4. It was pretty good, solid. So we did a bunch of stuff. We talked about the Regal scanner, which was really cool. Problem with this is that we needed a battery. We didn't want to use a lithium battery because it's dangerous. So we were looking for like a lawnmower or car battery. I have a lawnmower that does not work that has a battery. So that's the goal, which I'll touch on shortly. We got the like 2001 Dell laptop powered up with Windows XP 98 or whatever.
XP, yeah.
Yeah, it was amazing. We actually, I mean, so many stuff could have gone wrong. We had to fix the mouse. We logged into the previous owner's profile. We found the software used to scan. So everything's good, doing good. We just need a battery for the scanner, and then we'll see what other problems we have. And we found some scans that were already saved there. So the immediate obstacles is that we need a battery, and we were going to look into the software, which is right there, LPM.
LPM scan.
Right. I couldn't remember the middle letter. It was LM scan something. So the next step for this is to get a battery, plug it in, and see what happens if once we have a battery. Maybe it'll work. Maybe we got some other stuff to do. I went yesterday with my toolbox to go get the mower and take the battery out, and my mower is gone. It was there Wednesday, and
What?
Thursday it was not. Yeah.
What?
What I'm thinking happened. I asked my roommate or my housemates. None of us know where it went. Well, what we're thinking happens is we share a lawnmower with our friends, and so like we'll go get the lawnmower, mow the yard, and there's an old lawnmower that doesn't work and a brand new one. And I think somehow maybe they came and took the old one instead of the new one
Oh.
and just brought it somewhere. So highly possible I can still run over to their house and get it today. But yeah, at the moment, don't really know where it was, so I wasn't able to get the battery. So minor setback. We did find some floor plans. We were looking to find floor plans of Wallace to have a reference, since we were going to try and scan some of the insides. We found them on the tech website, and I made a notebook just detailing how we found them. And in the process of making that notebook, I actually found a different source for floor plans. It seems a lot easier, and it looked like it had a lot more stuff. It's kind of old. It's updated as of 2006, but it's on GitHub. You don't have to go through the school or anything like that. So it's pretty cool.
So I would say maybe add that to the add that info to the indoor mapping wiki page on the lab.
Okay.
So that it's all like we've got 2 ways of getting floor plans, this
Right.
way and that way.
That's what I did for the notebook. I said,
Okay.
here's this way, here's this way. I didn't realize we had a wiki page, but I touched on that in my thing.
Okay. Cool. Great.
So at this lab meeting, we were talking about floor plans, talking about georeferencing them. I believe we touched on geotiffs and world files. So next step would be, I'll touch on next steps later, but essentially learn more about geotiffs and world files and the process of trying to georeference the floor plans. We talked about this is a review from Wednesday. So we talked about all of us wanted, our next steps were also to start playing around in Pix4D with the data saved to the wiki. And then once we get comfortable, there's the possibility that we could just go scan something on a stick outside Wallace and then try and load that to see how, just understand the process better. We also wanted to start 3D printing something, get something small to print so we can watch it. Oh yeah, lawnmower. This is my lawnmower is missing. Or shouldn't be gone. So I started playing around in Pix4D. And I actually I couldn't remember where to save the files on Goose, like which drive.
Oh, yeah.
So this is just a minor thing, but so because I didn't know, I just wanted to play it safe. And so instead of using downloading files from the wiki to Goose and then loading them in Pix4D, I just used the sample files that they have on there. And I went on the wiki and read the pages on onboarding, which you linked in the Slack and everything. But I just wanted to, at some point, set up my Google Drive and everything so it syncs really well.
Yeah, let's spend a second. We can talk about it. So if
Yeah.
you go down to just open up the file explorer, and then so there's three physical hard drives in here. One is the OS drive, that's a solid state 1 terabyte drive. That's the C drive, and then D and E are each 10 terabyte drives.
Right.
So the way I've got it organized now is the D drive. If you go here and you go into users,
Yeah.
this is where you can create a folder for yourself. Do it when you're logged in instead of me, so that it's all in a
Right.
folder. But then you can just save whatever you want in there. There's no quota or anything. At the moment, I don't know how much drive space is used on D, but it's probably on the order of 7 or 8 terabytes. But I
Yeah,
think
there was like 3 terabytes left or something.
yeah, that's
quite a bit.
That's it. I'm glad you think so. Yeah, I'm sort of the view like, anything less than 5 is like, ooh, we're running out of space.
3 terabytes seems like 3 gigabytes.
Yeah. And then, so the F drive the E drive right here, there's a folder called Google Drives. And then you can just make a folder in here where you can sync your stuff. When you set up a Google Drive link to this and it treats it like a file system, it's going to cache everything to that drive. And then, so I used to have people just sync it to their D, which I think is okay, but this is going to make things a little better. Oh, that's Shashank. Great. Yeah.
So I would just make a file right here and say the Wilson or whatever, and then go to Google Drive and connect it.
Yep.
Okay, cool.
Yep.
Yeah, I was clicking through here. And if you like click in, you just keep going, and then eventually you reach like.
Yeah. So the way that Google like caches its files is super arcane. So the way you actually use it is once you set it up and you have this F drive,
Oh, okay.
which is how it looks. And then like if you go into like shared drives and you go near Earth Imaging Lab is here, 2 down. Yeah. So then all of that stuff sort of looks like it would appear on there, but it looks like a regular old file system and you can use it like that.
Cool. So excellent, good to know. So yeah, I used the Pix4D samples, which this is what it looks like when I load it in. I was expecting to be really good at this right off the bat, and I was not. As you can see right here, it says education guided tour. There's nothing prompting me. Like I don't know where the guided tour was. So instead, what I did is just click through every setting.
Okay.
So
So very
yeah. Yeah. So I tried to just look at all the tools, and luckily, like I at least understood a lot of the words here.
Okay.
Like I understand concept DSMs, DTMs, import point cloud for DSM generation, 3D mesh, run point cloud. So like a lot of these kind of make sense to me. This is a separate picture. I just wanted to save space here. This was on one of the bottom options, and so like I clicked through all these, and by reading them, I was like, okay, like I at least somewhat understand what these are kind of doing. And this was like the image setting. So when I clicked on the Google Drives on the wiki to see the files that we had there, or like if you click on the wiki files to load into Pix4D, it pulls up a million images, which I wasn't expecting. I don't know why. But anyway, so learned about that. These are just some more settings I clicked through. So Pix4D, I underestimated it. I overestimated myself, but at least it looks somewhat nice. And I figured if I ran through a couple tutorial videos, I'd have a basic understanding of like how to use it. Now I can actually load those other data sets in.
Have you been through the tutorials that Pix4D puts out?
Yeah.
Okay. Yeah,
Yeah.
those will be really useful. I'd go there next.
Yeah, it's on my stuffs. So also after I did that with Pix4D, I just remembered that we talked about reality capture. So I did the same thing. Reality capture has this thing on startup where you have to authorize the license.
Okay.
And it says it's like username, tpangle, password's empty. And I didn't and I just didn't want to deal with that. So instead I just like clicked run as anonymous, which
Yeah.
was without the license. Because I wasn't going to do anything. I was just playing around with it.
Yeah.
For anyone who hasn't used reality capture, it actually has like a really nice tutorial on startup, at least if you go in anonymous, and it walks you through like step by step by step by step of what the process is and what the options are, and it makes you like do the actual things. So this was like step 4, like first you had to import the images, set the views up and everything like that. So it's actually pretty easy to follow, pretty nice. But those are just my experience running through both of those.
Great.
So summary, the Wednesday meeting was really awesome. I got really excited about the Regal project and booting up the laptop. So my goals for the week was number 1, with the photogrammetry, watch the Pix4D tutorials, set up the Google Drive, and then get some more experience in both of those, like hands-on. And then possible future goal is we could try and scan something and then understand the scanning process more. As far as the indoor scanning project, find the lawnmower and get the battery. This is pretty easy, but if anyone already had a battery, I guess we don't need to do this.
I do have a battery. If you find that you can't find the lawnmower, which you may want to find for other reasons,
Right.
let me know, because I also have a broken lawnmower with a
Excellent.
batteries.
I hope yours doesn't go missing. Then we could also start continue the process that we were doing with the floor plans, which I believe, I'm not totally sure about this, but the next step would at least just be to learn more about GeoTIFFs and world files.
Yeah, my hope is to record like a little 2 or 3 minute snippet of like, here's kind of what I mean, and then you can see what I do, and then you can maybe kind
Try
of
it,
take
yeah.
off from there. But I think if I record something that's like at 5 minutes, like that'll save you a few hours of like
Okay,
trying to figure out how it all works.
awesome.
A quick demo.
Yeah. Another part of this was trying to see if we can get a newer version of the LPM scan software on that ancient computer. I forgot the middle letter, so I didn't do that already. And then once we have a battery, we can actually boot it up and see what happens, if it'll scan or if there's another problem to solve. Either way, it'll be some good progress. And for 3D printing, just pick something small that won't take like 30 hours.
Yep.
And so I can try and print something myself and see how that goes. But overall, I wanted to start just accelerating progress on all of these. I really enjoyed, like, we didn't really run into that many problems because we just didn't have a battery on Wednesday. But I really enjoyed like seeing what happened and being like, all right, we solved this thing. And then now there's like 4 more problems. We got to figure those out. It was really fun. So looking forward to going forward with that and everything.
Thanks, Barrett.
I have a question.
Yeah.
Could we, so it seems like a lot of us are going to be doing, so like structured motion scan or drone flight or whatever, in which we will need GCPs. And I was wondering if it'd be cool to do like a lab workshop.
Yeah, that's a good
where
idea.
We learn how to use the Reach mobile base station, how to
Sure.
collect points, how to go correct them, etc.
Yeah.
That'd be super helpful.
Yeah, let's do it. So Gunjan's got a little bit of experience with it. And then by next week, you'll have a little more experience with it.
Yeah.
And that should be enough to kind of get things rolling. We probably need, there'll be some field collection, so that's pretty time intensive. So it may be a couple of hours required to do something like that. But yeah, let's do it.
Awesome.
Is there water in here? Can I put water in a mug?
The easiest one that I know of is there's a water fountain. If you go around the corner and back, there's like one of those that you can put a water bottle in.
Oh, okay, cool. I will do that.
Maybe I'll set up a win to meet for
Sure.
sometime 2 weeks from now. That's
2 weeks would be really good for me. Next week would be a little bit difficult.
Yeah.
But we make the text of this bigger. It's just.
Yeah.
It's very small. I know when you're not right in front of them. Is there a hotkey for this? Yeah, I'll just have to just go.
I know my computer, but I have a Mac, I can do like Control Plus, and that like zooms the whole thing in. But I don't know if it does.
I guess it's Windows is good because that's the control and scroll.
Yeah, but I don't know if we do it for the OS. That's okay. I think we don't need that. And we don't need that.
So I have a question.
Oh, you want to go next?
I don't have any slides, but it's really that you do that. But can I just talk a little bit?
Yeah,
about
yeah. Let's see that.
Next week I'll put them together. I didn't really do a whole lot this week because I've just like learning about I'm working with the Reach RC, yeah. So I took it out on a poll and just did it in single mode on like points, like 5 different locations. And so I'm looking into the PDKs, the food processing looking at tutorials, and I think it's pretty doable. I was like reading, I watched a video and the documentation. I think I can set it up on my laptop.
Okay.
Pretty easily. The one thing that I didn't do when I was getting but I'm single mode right now. Great. But I didn't when I was watching I didn't log, so I didn't get any of the log information.
Off the unit.
Yeah.
Okay. So yeah, you'll have to pull
I'll
that.
have to go do that again, right? So I'd have to go back out.
No, all those automatically get recorded. So you'll just
Okay.
have to like plug it in,
Okay.
and then you should be able to log in. And then
Okay.
if you go to logs, it'll have them all listed. And you can just
I
download it
just
that
go
way.
down the But yeah, that's kind of what I'm gonna be doing next week. We're going into that. Presentation. Yeah, also, are you free after any of the meeting?
Yeah, so I'm free after this until 12:20, and then I'm in Logan until 1:15, and then I'm free until 2:30.
Okay, I'll come back at 15.
Okay.
That's cool.
Yeah.
Okay, awesome.
All right.
So
You done?
then-
Oh, did you bring your those wires that we need to
Yes.
connect?
Yeah, I brought one. Yeah.
Oh, wait. It's so much easier to see now.
Yeah.
I had another thing in Plix 4D which happened last semester when I was remote connecting for my remote sensing class, which is like the resolution was kind of changed or something. So like the words on the Pix 4D were like super tiny.
Yeah.
Yeah, it actually happens. Like, did you try to like move it from your laptop screen to your monitor screen?
Right.
That happens. So yeah, that happens.
So I'll probably try and lower the resolution or something. I think we had the same problem in Verdos, but it was like significantly worse. Like you actually just couldn't use parts of the program.
Is there a good way to hide that? Or just not?
Yeah, hit the minimize right there. Right?
Yeah.
Yeah, that works. Great.
Alright, so I had a pretty I guess it was a relatively slow week this week. I was just pretty busy with other stuff going on. But looking at the Regal LiDAR scanner and then kind of taking a look at floor plans, I'll go into how the floor plan stuff works. So I got a couple images of our adventures on
yeah.
Wednesday.
I meant to, I've got one or two as well. I'm gonna,
Yeah.
I'll throw them in next week's lab report. I forgot to put them in this week.
So the scanner itself is obviously this thing right here, and then here's the ancient computer that I was surprised a little bit that we got it to work as well as it did. Just because I've got like a couple old computers at my house and like no laptops or anything like that, but like computer from like 2008 or something, and I can't get it to like run a single program. So I was surprised that it was working as well as it did.
It's got that laptop has an actual 3.5-inch floppy drive.
Oh, wow. The mouse would move on its own, and we unplugged stuff and couldn't figure out why the mouse was moving on its own. And then it just fixed itself, and then we got an error message, and it pulled up in German for some
Yeah.
reason.
There's some interesting stuff going on there.
I'm glad you documented the power requirements. I forgot that I thought I was in my head that it was 14 volts as a maximum, but it's 18.
I think it was 11 to 18.
It says it on the scanner. I also think it's 11 to 18.
That's great. We can maybe use some O'Reilly batteries to.
So yeah, still looking for the optimal way to power it. With the lithium batteries being maybe a little bit sketchy to use. We don't want to cause any explosions.
It's
and
just the
fire.
shorting that I'm worried about. It's
Yeah.
like there's a bunch of sort of like open
Of course.
connectors and they brush against each other because we're not.
So LPM Scan is the name of the program, and when I went to kind of look it up, and I didn't do a ton of research into it yet, but I kind of Googled around and looked for what I can. And what it seems like is that it's a Regal specific application. So I don't know if it's been updated recently. I couldn't even find it for download anywhere. And I'll have to go on Regal's website and look for it. With this scanner in general, I'm just like, I've been having trouble finding a ton of information, but from what I can tell, it's like a Regal specific program that goes with their LPM2K models. And this is like a something 2000 or 3200, something like that. It was pretty hard to find any specific information on it. And then we also found a couple older images that had been taken with what we assume is that scanner. Not sure, but these were in computer files. It looks like a test image with maybe something on a wall or something on a desk. But yeah, it's going to be fun to kind of pull it out once we can get the battery stuff working and see what sort of scans we can get, what sort of quality. Those are just intensity images and I guess the range image. And then floor plans. So as Barrett was talking about, there's two different options and two different ways to download the floor plans. So the first one is on that GitHub page. And on the GitHub, there's a link to a zip file. If you can see my mouse, it's like right there. I think the whole thing is only like 15 megabytes. And that has every single floor plan updated 2006. That's like available to download and stuff. And what I realized is that the images are super high quality from the zip file. I just don't know if that's the way that they download it onto my computer or if the way that they were just kind of in there. I have this one here. This is from the zip file. It's not bad, but I just don't think the image is quite as high a resolution. And it's not the exact same image as the one that I'll talk about in a second. But here's Wallace Hall. This is the second floor. So we're, let's see, we're right here, I think. Right here.
Yeah. So there has been some.
There have been a couple
Some changes.
Yeah. And what's interesting is I think the last time, like, I guess the exterior or like main parts of Wallace Hall have been updated, I think was 1992 is what I was reading. So no like super major changes to probably the shape of the building as a whole. The atrium still looks the same and the staircases and things. So that this is from 2006 for at least 2006.
So they don't have a CAD file or something like that.
I'm looking to find them and I just can't find them anywhere. I've been looking into options in terms of like contacting, there's like a GIS and space department or something, looking to contact them and see if they can provide us with CAD drawings, but we can't find them available online anywhere.
Yeah, there is a program that Tech uses that we found when we found this, that you can like try and submit a request and they say they have more information. But this was like we were quickly trying to find stuff without having to like send a request form
Yeah.
and figure all that stuff out.
And I think one of the request forms just didn't work when I tried to open it. I got a 404 or something like that. So the second option is available on Tech's website called the Secure Space Inventory. And I can actually go to the link. If it's, you have to have an active Tech account to log in. So you have like building location maps. This is going to be like your campus map or something like that. Like for example, that's what is pull up campus. So and this is all I could find at first, but then just because none of these three links go to actual building information, but if you click this one at the top, then you can log in here. And you can go into, I think it's major buildings,
I got in building and room information as well. So I think there's a couple different ways.
and then Coach Wallace Hall 115. And it's got information about like original construction year or like most recent update, things like that. Then you can look at the floor plan. So like second floor is ours, and this will download as a PDF, which is nice. If you want to save it, I'll just leave it like this for now because I have the image on the next page. What's nice about these ones is that when you're downloading the zip file, you have to do everything in bulk. And these you can kind of select the images that you're looking for, or the floor plans, like specific floor plans that you can download just ones from Wallace Hall. And I think that the images look to be a little bit higher quality. So I have one here. And it's just the resolution just seems a little bit better. And I think it's a little bit newer. If you take a look at 237, it's updated.
Oh, yeah.
So here's the lab room now. And this one has, I think, what appears to be the more correct version. I don't have a date associated with when this specific PDF was updated. But if you go back, you can tell it's different. And there's a couple different things. And it just looks like it's a little bit higher quality, a little bit easier to follow anyways. So I like them off of this website a little bit better.
None of these have any kind of measurements.
No.
No.
So I guess like if you really want to use this floor plan, you need to have some measurements.
Yeah. It would have to be, I think we would just have to georeference it and like try to do that as quietly as possible.
Well, I think so. I think one play is going to be just using these images and georeferencing them and then sliding them into whatever we're working on. But I think the second one is sort of figuring out who has the CAD information and how you access that. Which probably you spend a little time on the website trying to figure that out. And at some point, it's easiest to send an email.
Right.
Like, hi, I'm working with Tom Pingle over in the geography department on this project on Indian geography. How can I find the CAD files? And they'll be like, hi, that's great. Let me tell you. So save you some time. Plus, talking to people is really nice
Yeah.
sometimes.
So that's also one of my goals for next week. I'm still looking to trial out the posits, get everything set up, and take that through like the first kind of test drive, that sort of thing.
Yeah, that's where I think, that's where these images are going to come in really handy because once you get it set up,
Yeah.
ideally you'll be able to import that and then
Place it over top.
right, and then seeing your dot move around on an actual
Yeah.
floor plan is
Because
pretty
the
sweet.
posits, I think, is accurate to like 10 centimeters, or at least that's what it's supposed to be. So it'll be nice to have a higher quality image with measurements and stuff that the CAD drawings would probably have, which would be a little bit easier to use for reference to the massive floor plan itself. Not that the floor plan is useless, but the CAD drawings would be a lot easier to work with probably. So looking for CAD drawings and then kind of working to georeference those into their correct locations. And then going through Pix4D and the photogrammetry tutorials on the lab weekend, kind of figuring out how that stuff works.
I wanted to add when I found the GitHub source, there's another way to do it without using the zip. I don't know if that means that those files are better. But yeah, this is all, I made the notebook like very like including, like I wrote down all the steps and had pictures. But so if you click floor plan directory, that hyperlink right there, and then just Control F,
Okay.
and then go 0115 SA, and yeah, 02.
Yeah.
And so that says, you can see if this one's, it's probably the same one, I'd imagine. Yeah, same one.
Yeah.
What? Yeah, why are they,
Gifts.
why do they have a mirror?
Yeah.
What's the project that they're working on that they're distributing Virginia Tech floor plan?
Oh, I don't even know. This seemed totally like some guy just made it, put it
Yeah.
together.
Go to that peterpages.github.
Yeah,
But
go back to the GitHub page.
yeah, top level. Do you have like an explanation of what he's doing?
Static copy of former peterpages.net. Peter Pages just didn't sound like a tech sponsored thing, but
Yeah, keep going.
Yeah. This is the most I can find.
Okay, last time we did 5 years.
Okay. Yeah, it's not so important. If we've got the updated diagram floor plans, that's probably where we need to be. So we probably don't need to pursue this too much further. But good to know that it's out there.
I don't know how we didn't find this the first time because for some reason
I found it. This was the first thing I found.
when the first one I found was the tech one, and then when I was putting together the notebook, I Google searched to retrace our steps, and this was like all of the links. So
Alrighty, Colleen, you want to go next? Still with us?
Yeah, sure, I can go next.
Okay.
That's not the right. Alrighty. My presentation covers the past 2 weeks because I made a presentation for last week, but I ended up going to the ER Thursday night, so I was not feeling great Friday. I got both those goals done, so that was really exciting. So to simplify my job for LCPI, because I didn't want to have to change the whole label the entire time, I just changed the scale factor and added this little bit right here. So that way it would automatically add the scale factor into the label. And like, I know it's not complex, but I'm pretty proud of coming up with that myself.
Be proud.
Yeah, it definitely made it easier because then I could just later on stick it in a for loop.
Right.
Since I was running like a whole range of coefficients, Dr. Pingle suggested putting it in a for loop. So I did, and it takes a while to run, but it leaves me to do other things in the meantime. As I said, takes a lot of time and memory. That's what it felt like looking at how much time and memory it was taking, just waiting. Unfortunately, I had to rerun everything. So this is your first reminder to double check your work. Because I ran everything and then Dr. Pingle pointed out that I'd missed this connection here and this connection here. This connection was in the table itself, but it was in the very first line. So don't put stuff in that very first line if you're planning on running stuff between it. It goes in the second line. So always triple check those links because you might have to rerun everything like I did. It took, as I mentioned, it took a while to run. It ended up running for like 5 hours for all of the Pingle stuff alone. Because I started it at like 7:15-ish. So it was very exciting once it was done, but it definitely takes a while. So that was all last week. Starting this week, I started running things for the accuracy assessment. I wanted to cut the Inca roads to the shape of the raster, and there was just really no easy way to do it. It wouldn't let me run raster to polygon. I couldn't just clip it from the raster. And so I just had to make a shape file of approximately the right shape and size, just to like clip it. So that way it didn't have a bunch of data that didn't need to be run at the moment running. So it saved me time for now, which I'm very happy about because that's a lot of the road system. For reference, I think is like 1,500, no, either 1,500 or 15,000 miles. And like the buffer took long enough already with the little bit that I clipped out. So unfortunately, this is double check your work counter number 2. But good news is we're averaging only 1 a week. So I'm made 100 meter, 500 meter, and 1 kilometer. I only did one with the 100 meter. Like I only tested one at the 100 meter because it was really bad with its accuracy. It did not match much at all. But as you can see in this little buffer snippet here, I happened to take a picture of my mistake. I labeled it 1 kilometer, and then the D was for dissolve because I had run it without the dissolve at first. But I made it 500 meters. So double check your work. And that's why down here, I had like the same results and thought that's not right. And Dr. Pingle was like, yeah, that's not right. And it's like, okay. So double check your results. Initially, I did not dissolve the buffers because I was hoping I could get it from like point to point. So like from here to here, I'd get a result. But Dr. Pingle said that that wasn't really necessary. So I just dissolved everything into one file and it saves me time. So I don't mind that. Summarize within fun. For some reason, when I tried to add a statistic, I guess I should have probably, if I wanted to run it this way, I probably should have added a field first, now that I think about it. I literally just realized that now as I'm talking. But so I got the error and this is how I ended up running it, was just like this, and it gave me all the information that I needed, which was really nice. I forgot to take a picture of what the results look like in ARC, but basically it gives me a number of how much of the Inca, how much of the least cost path is within like 1 kilometer of the Inca road. So like how much of the least cost path is within whichever buffer I did. And so I realized I could run multiple at a time with summarize within. So I would run the linear and the aerial at the same time to test out the Pingle stuff. I also had to add the length to each of the LCPs because that wasn't already in the attribute table. So that's a real quick thing. And then you just look at the statistics for like the total length of it. And I believe that's in that's in kilometers right there. And so then I got this nice little table, or I made this nice little table on Excel. And it's basically So there's about a 2% difference for linear and aerial at the 11 coefficient, but there's less than 1% for 1 kilometer. So since there's a bigger distinction at the 500 meters, that's what we decided to go with for everything else. I also ran it with the 10 just to see what would happen. And then I set this up yesterday to run it, and I was gonna make a graph, but I ended up being so tired when I got back that I fell asleep right away. But all of it's been run. I'm pretty sure it succeeded because when I left it, it was running this one right here. So I'm gonna take a look at those results later today and add them to my nice little table. Goals for next week, look at the results of all the LCPs and the accuracies. Dr. Pingle wants me to create a graph where it's comparing basically the linear and the aerial LCPs for each type. So it's like 2 bars per algorithm, whether it in like linear versus aerial. Write up some of these results from all of this and the methods because a lot went on and I should write it all down, even if it's just bullet points at this point. I realized that I forgot to put the code into archive-worthy format because it's a little bit of a mess right now. And meet with Dr. Pingle to talk some more goals. Also look for a new place to live in Blacksburg because Thomas accepted an offer from Twerk. And I'm currently in, okay, cool. Pairwise buffer GP tool, got it. I'm currently able to stay where we are because we got an air purifier, but that's more of like a short-term fix. So we got a tour set up on Monday, but I'm currently looking for places if anyone knows of anything.
Thanks, Colleen. All right, Chandler.
Give me 1 second. Pull up my slides. I'm just gonna screen share from here. Is that cool?
Sure.
My research was kind of just going off of my goals from last week, which was basically trying to figure out importing information into Blender, like photogrammetry data, point cloud data, etc. So I downloaded an add-on called Blender GIS, which was successful, and I tested it. This is a screenshot of Annapolis, Maryland. I was just using my hometown as reference to really see the potential for like literally getting this data from anywhere. And I've been experimenting with it past week. Like I'm looking at one of the Rocky Mountains on my other screen, but yeah, this is Annapolis. So you can download base map data from a variety of sources, and the OSM data is categorized with a variety of things such as buildings and land use data and waterway data. And these buildings have their height data registered, so it can generate a really powerful model of a city within a few seconds. The elevation data, there were a couple options for that, marinegeo.org and Open Topography. However, the Open Topography option wasn't working for me at this time, so I'm gonna keep trying it, see if it is just a today thing or if there's an actual problem with that aspect of the software. These are the models I generated of Annapolis, and I did these in literally 10 minutes. So I was really kind of impressed by that because I didn't have to, all I did was install the add-on and it just had all that there. The topo data was a success. This is a fairly flat area, so there isn't a lot of topo data, but you can see there was a pretty good sized bulge right there. So, when you look at things like mountains and whatnot, like it, it actually really does show the topography. I know that there is a vertical exaggeration feature to this, so it can be good for like identifying features in more high slope areas, which could be useful. But we have other softwares for that as well. One thing that I was a little bit disappointed by was the tree data was not included in this. And as you can see, like the streets kind of look just normal flats, just using like a basic Google base map. So I'm gonna test that, see if I can use some like Blender nodes and start like augmenting this data to create a more like visually appealing render. This was just the stuff that I was talking about during our undergraduate research meeting, where I was testing a 3D point cloud visualizer in Blender to see how that could work, and maybe getting like cloud compare data in here as well. So I downloaded that, and nothing's changed since then. I was missing when I tried to download the cloud compare, was missing some data, but using the test poly file from Sketchfab, that worked. So I'm going to be working to do that over the next week, trying to get other kinds of data and just learning the other softwares to see which would work best for landscape architects. And yeah, so just going to complete the Pix4D tutorials, 3D printing tutorials, and I'm going to work with Blender to try and increase the render potential of that map.
Yeah, this is great. The Blender stuff is really coming along really well. I'm really impressed. Can you go back to the Blender slide where we get the building extrusions?
Yeah.
If that worked in 10 minutes for you, that's a lot faster than some of the other workflows.
Yeah, I can, I've just been messing around with it this morning before we got on, and I just kept it open, but like I can literally zoom in anywhere in the world and just like download the base map data with the click of a button and then just extrude it with another click of a button. I was really impressed by the speed of it.
Yeah, and it's pulling in. So are the building footprints coming from OSM?
Yes.
Okay, great.
One of the things you can also try, Chandler, is like the combination of Google Earth and the Google SketchUp. So you can also like download the KML file, or actually you can do it from the Google SketchUp. You can just type in an area and it will download the data using all the, including the extrusions as well, like the roads and everything, and also an image of that building overlaid on top of the extrusion. So if you're looking into the visualization, but you can also do a small experiment with that as well. And Google SketchUp is also like very fast.
What is it called? Google
SketchUp.
SketchUp? Google SketchUp?
Yes, SketchUp.
Oh, are you talking about the? Yeah, I know SketchUp. I didn't know if, like you meant like there was another Google. Yeah. Google SketchUp. I love SketchUp.
So there's two other things that I would recommend. One is try to track down some good sources for that tree data, because I think that's probably going to be important for your work in landscape architecture. There are lots of sort of global tree databases out there. If you do a little looking on your own and see what you come up with, but there are some good ones. Virginia Tech has a tree database. The last time I looked for it, it wasn't all that easy to just download and use, but maybe that has changed. It's been a couple of years.
When I was looking at the Tech GIS for the CAD floor plans or whatever, I ended up on like the Virginia Tech's GIS thing, and they have like a bunch of links to a bunch of different like layers they've created. And I'm pretty sure like the trees were there. They had like DSM, DTN, like all of this, and it looked like you could just hit a nice little polished button and it would download for you.
Okay.
So you could just Google search like Virginia Tech GIS department, something like that. It'd probably be easy to find.
Okay. Yeah, maybe you guys can swap notes on Slack and
yeah.
And then the other thing was, oh, so OpenStreetMap also has like a 3D building spec. I don't know how much it gets used, but if you Google like OSM 3D building, we can actually do that right now here.
I can stop sharing.
Yeah, stop your screen share and I'll start mine.
So is OSM like a company kind of like art or something?
So OpenStreetMap is a project.
Okay.
I'm sure it's got some kind of a legal status. But basically it functions as a global public database of geospatial data, mostly related to the physical environment. So it's not like statistical data, it's like buildings and streets and
Right.
sometimes trees and lots of stuff like that. So kind of, stuff that would show up on a Google map would be like,
Right.
but it's all free and it's user contributed. So users can go in and edit it and make changes and add things. So it tends to be, especially in places where there isn't sort of an active development of geospatial data, like it's a great source of geospatial data. And I always encourage my students to use that. So in analysis, we'll have a bit where you're going to download and use OSM data to like solve a problem where like it's hard to get data on stuff, like this is just user contributed.
Right.
But because it's user data, it can sometimes be a little spotty. So some places are certainly better not than others. But Chandler, all of this stuff is essentially in the database. So this is a rendering of it. But all of this information about like, whatever this building is and whatever that building is, like all of this is actually in the database and downloadable and so importable elsewhere. I don't know if, a lot of what you're seeing here is just sort of these buildings. So it might be that the stuff that you're already doing is tapping into this, but you might see if like, I don't know if we can, let's go to New York. All right, so like here's New York, and you can see that some of these buildings are mapped in quite a bit of detail, right? Again, they're really tall, but they're also more than just extrusions. Some of them have some real detail to them. So you might look into this OSM 3D stuff and see what's around.
Some good keywords might be, so just search for municipal urban forestry tree databases for like a specific place, I guess. And you might be able to find like individual, because a lot of municipalities have probably a database of their cities and their trees.
Yeah, it's urban
Somewhere,
forest resources.
Yeah, maybe poke around on that and see. And then we've got a forestry department that's got a strong GIS. So again, this is where an email, if you do a little searching on your own before you start reaching out to people, so that's always a nice thing to do. Maybe JP Gannon would be a good person to.
Dr. Wiseman.
Wiseman?
Wiseman. He's the urban forestry professor over there, and he would be the one to talk to you.
Okay.
Yeah, that link is urban forestry BT street tree selection tools. That's definitely good. Who knows?
Yeah. Good options there. All right. Well, Shawshank, it was good to see you. I see that you popped in about halfway through. Hello.
Hello, everyone. So I could not join last week. I was a bit ill last week. I just popped today.
Good. Yeah. Well, I hope you're feeling better. Good.
Yeah, I'm feeling good right now. Yeah.
Okay. All right. Well, we'll wrap up. Taryn, thanks for joining us. I hope it was probably some of the stuff that we've talked about. So
Yeah, it's been fun. Thanks for having me. I'll be sure to be back next week.
All right. Sounds good. All right. Well, thanks everybody. We'll see you next week.